5 what?
Bigger than K6.
Is it?
No.
Yeah, so you get a what?
2.
Yep.
And here you get some crazy number, and here you get some crazy number. To get it normally it's distributed.
Yep.
To get what normally distributed?
Also you got one group and you got the other group.
Okay.
Right? But I wanna, so if y is in 1 then I get one group, and if y is 2 I get the other group. So go
If
down.
this y. Okay. So where do you see these groups?
Well, the normins are the groups. So you do the groups first on x1 and then on x2.
So first you find the group that's like here, and then you find the group that's here. And the same for this.
But look at this guy here. So if y is 2, right? Then these are like smaller numbers on the x1.
Yes.
There's the second group. There's a mean of -2. Wanna move it around?
Move it around.
Yeah, put a -1 in there.
Where? Here. Okay.
And see.
What was it? -2. Okay. So this stuff here and this stuff here is stuff that's like supposed to be truth stuff that we don't really know.
Yeah.
Can I make it green or something?
Okay.
Just like that.
No, don't change the color.
Oops. Oh, I can almost not see it. What else is there? Is there anything else like that?
Well, these are the parameters that you pick, right?
No, it didn't say that earlier.
Well, these are the parameters that you picked to
These
generate
are,
it. Yeah, to guess, to start guessing, but yeah, okay. You know them.
No.
This is the truth that you don't know.
Yes, that's why I don't pick them.
Yep.
Okay. And this is the solution thing. Can I make it yellow? Okay, doesn't matter.
So the key thing is to figure out how this works.
This thing. E2 minus K9 squared plus F2 minus K10 squared.
Called the Euclidean distance, or the regular distance.
Yeah. Oops. So you're just using that point. It's just one point. And this is the mean for the point.
Mean for the second group. You can do an error rate. So if you insert something in, if you insert another column, say error. And that's gonna be d minus i.
D. Is D?
The actually absolute value of that. So we can sum it up. Okay, and you can say here errors.
Here.
You can do sum of j. This is like sum is so good you can actually click on the j.
Okay.
Okay. So this is pretty good, right? But like, let's say let's make this to 3. Standard deviation to 3. Okay, and now let's start from something, you know, like 1, 1, 2, 2 or something. Okay. So let's copy and let's see. No, you have to do values.
Oops.
Okay, I'll do it again. Okay, that's 38 errors. Okay, let's do it again. So the number of errors gets smaller.
It's getting bigger.
So it get bigger.
Oops. Did I mess it up when I did this?
No. I think it's flipping around, that's why. Okay. It wants to get the number of errors to 50.
Okay.
Because, you know, if it flipped around, the big one's
Okay.
going.
Fine.
And 6. It's slowly like getting these things. You know, every time the mean moves a little bit up, the other mean moves a little bit down. No, it doesn't do anymore. That's not.
Maybe one more time.
No, it doesn't. It's no, if it doesn't change the number of errors, if it doesn't flip any,
Doesn't happen?
no, this is discrete. So if it doesn't flip any of them, that's it.
Okay.
Like the same numbers, but it's pretty good. You got a 3 and a -4, 3 and a -3, minus 1.8 and 0.8, -2, and, you know.
Okay.
So the way I would do it is I would paste it based on the ordering. So I would say whoever has the smallest x1, right? So this or biggest x1 is the first, right? In this case. So I would say whichever group has the biggest x1, I would paste that as x1 on the next one. In order to solve this problem of labels, you could do this. You could take these two